Hello, welcome to the stream. It's another Sunday. We're going to do some more databases. We're going to be testing HanoiDB today. And I mentioned that it's going to be potentially shorter stream. I'm going to have to cut it short today for personal reasons. But I also have some news if you have not followed anything I've said on social media. But I have a new job starting tomorrow. So I'll be going to work at Grok. Grok is a company that makes hardware for doing AI/ML inference. Specifically, it's really good at LLMs, which is interesting. But I'm going to be working on the team building the software that helps bring up and manage deployments of this hardware. So it's going to be a pretty interesting set of problems. I'm excited about doing it. And you may have seen also Fable is shutting down. So I've been working on finding my new position for a while. And I really did appreciate everything that I learned at Fable. And the colleagues that I met and got to know there were really great. So new chapter for me. And I'm excited about that. So I get started tomorrow. Anyway, we're going to work on testing, right? So we started some testing last time of the public API, but I think it's worth making some tests for the inner components that aren't exposed by the public API. So I think we're going to work on that. We might do some reorganizing of the code as we do that. But we should be able to get some decent testing of I'm hoping the nursery and the writer, because the writer is like so core to everything. If you can't write a valid data file, then you got problems. So we need to test that pretty heavily. All right. If you have any questions, please feel free to drop them in the chat. If you're not familiar with what we're working on, I'm happy to answer those questions too. But it's just going to be mostly testing today. So let's get started. I was flipping through some of these files. So we've got the writer file. We've got a lot going on in the nursery as well. I think the nursery is like super important to test because we've got this is where all of the activity of writing new values to the database happens, and all the rest of it is just merging and reading. So we want to make sure that this is very well tested. This is the core. And then everything builds on top of that. And then, of course, the writer is what lets you take the data written in the nursery and promote it to higher or deeper or larger levels. So we want to make sure that this is really well tested as well. We could also, this is something I've been thinking about for a while. We could look at dealing with the format. And one thing I want to consider is that since we are going to be creating things in the future that are different than what the original Erlang code did, and we've already kind of diverged from the Erlang code. For instance, we're not writing Bloom filters when we should. But we have this magic 4-byte, pretty typical tag at the beginning of each file. Then I think that we should also consider making a new version of this, so HAN3 possibly for our Rust version, and still being able to read it, but then all the ones that we write, since they're not going to be backwards compatible with the Erlang code, we're not using the same Bloom filter, for instance. We should consider bumping that version or specializing it in some other way. Okay. So we can deal with that later. But we could also be testing some things here in this um, in this file. Most of these would be, if we have good tests for the writer, we can open them with the stuff in the format module and make sure that that's working correctly. Yeah. Okay. So let's start thinking about how to test the nursery. And I think that we're going to want to make some test helpers. When we started the tests for the public API last time, we did a lot of this, temp dir and then closing it at the end. And I think I'd like to make that into like a declarative macro that we can just put inside our test, or or around our test or something. I don't want to make it too complicated, but writing this every time is kind of a pain. So let's make a test, and we'll put is it bang? I always forget the direction of that. Config test. And actually, we should probably do. Let's rename this real quick. Rename test utils, and we'll just do it this way. Test utils. That way, we're not exporting that. Any of the modules inside our library can use this inside our crate, but it's not exposed. Yeah, so macro export. I think we can do this. Macro rules. Let's call it with temp dir. And I'm going to have to refresh my memory about how to do this. It's been a while since I've written macro rules. Let's look it up. Macro rules. That did not help. Macro rules scopes. Macros by example, that'll help. Okay, so we've got an identifier. We call it with temp dir. And the match. Right, so we need to give. Okay, so what I think we want to match is, let's see. Right, so we can do something like this. We can match. I think you can do like so. And then we'll do dir, which is an ident. And then block. Yeah. Block. Okay, we'll see, because what I want it to look like is something like with temp dir and then we do dir in here, and then you can use that variable to initialize like opening the directory or where to put something, right? So let's see about doing that. This is the what we want this to look like. Okay. So this is going to be really simple. We're going to say let dir, and remember you have to fully qualify things inside macros, because you can't assume anything about the existence of these symbols in the outer scope. What did we do here? So that's temp file tempter. I think it was unwrap, and then we do T. And I think that it might be safe to put that inside brackets, such that it is always safe for any expression to go inside there. Dir close unwrap. Okay. Okay. And let's write a little test for this. Except this is not exactly how you do it. You do something like this. Actually, I need to get my syntax correct. The other possibility is you don't have to have these if it's a block. How does that work? The other thing we could do is something like a fat arrow. What if we did, instead of, we did this, like so? Does that work? No. Yeah, I think the problem here is it doesn't like... Now we could possibly do that. That would connect it. Does that work? Oh, yeah. Here. Leftover tokens. Can we remove that? The syntax the syntax of declarative macros are weird. Like, it doesn't have any problem with this. Expected semicolon. Huh. Okay. Why don't we go look at some declarative macros that are in other crates? Because I think that will help us. And before I go too far down this Okay, tokens matched after a TT fragment. Block expression. Yeah. It's like order matters. Right, so I think we want also up here to do macro use. That way this macro is exported, can be used outside. Right. You know, this is not necessarily helping me at all. I think it'd be better to look at some examples. So what's a good example? Let's see. I think we had some in when we did the tree sitter work. Where did I put tree sitter? This is it. Yep. So, oof. That's fine. Okay. So, here in language, we made, and I was just looking at this the other day. Okay, so, I mean, this doesn't necessarily help me because this is a very, like, function style. The thing is, I think you can go like so, and it's the same. Like that doesn't produce. Yeah, fine. We don't care about that. That doesn't produce a problem. So okay, so I guess the key here is whatever boundary symbols you pick for the arguments to the macro, they need to be the same. So we will go ahead and close that. We don't need that. So we need something like, will this work? And maybe we go back to okay, what's wrong with this? Expected block. Okay, so I think that this probably needs to be item. Yeah, so it can be any item. It could be a single expression, or it could be a sequence of expressions. Now we might want to do TT here, actually. Yeah, that's not going to work. Let's say item. And what happens if we do world? Does that break? Yes. I'm beginning to wonder whether this is actually saving us anything. Now we could do something like this, and At which point we should just make a function that takes a closure, because the macro then is not worth it. The other thing that we could do, which I'm not convinced of yet, is make this be an attribute macro, because you could use macro rules to do those too, and have this be an argument, right? Right, it would need to be that. But then we have to put this annotation on everything, and that kind of sucks. I don't know. I think this is probably too deep of a tangent. Let's abandon this. I'm going to close this file, don't save, delete it, and then we'll delete it from here. Okay, so let's go into nursery, and let's make a test module. Okay, so what are some, so we need to use superstar always. What are some interesting things that we should test? I think, let me collapse all of these methods. So we want to test creating a new one without recovery, right? We want to test recovering an existing nursery. So that's where it never flushed the nursery data. So it's just a log. We want to test writing enough values to force promotion. We want to test writing enough values to force merging. All right. We want to do a write read back cycle. That's a pretty basic one. And then we want to test writing values and getting back their entries. So not just, well, and it's actually just get value. So this would be part of the write read back cycle. Let's say including deletes. Yeah. Right. So I think that covers most of the functionality here in the nursery. Let's get started. So let's create a new one without recovery. Let's call it fresh. Say fresh nursery. Right. And let's say const min level, just for the sake of keeping this consistent. We'll say that's 10. That's kind of defined in some other module here, and is passed in. But okay, so And we're going to use tempter, temp file, tempter. Okay. Okay, and then we're going to say let nursery new, and we're going to say dir and min level. Okay, so we want to make sure that that this succeeds. So we want to unwrap, right? And so now this is a nursery and this is a vec of commands, or it's option command. Okay. So we can do, since this is empty, we can say command is none. Fresh nursery wasn't empty. Okay. There's not really a way to say if this thing is empty. Say maybe we can make some functions for that, like total size, right? Generate, not pub crate. We could do, so interestingly, like in this recovery, no, it says total size is 0 regardless of whether we recover. Obviously, if we recover the nursery log, that thing has to be promoted immediately. So it's going to be empty at the beginning, the nursery. We don't put those back into the nursery, right? Because here in the recovery, if the log file doesn't exist, then we, have nothing. But then we go through the hoops of loading in the data, and then we write it out to this. So we could do something like we could assert that this file does not exist. That's also a useful thing. Okay, standard fs exists. Is there a refute? No. I think on this we need to do two. Because here it's fine passing this as a, an asref, it implements asref path, right? Maybe we do asref. Okay. Okay, so that. Okay, so we can let's see. Recovery data was written on fresh nursery. This should never happen. Let's get an assertion. Uh, we could say assert equal nursery total size 0. Like, that's a dumb thing to assert, but we can assert that. We could say assert nursery dot data dot is empty. Now, the reason we have access to this is because this is basically the same module, or it's a child module of this one, so it has access to the private fields of the nursery, and it's fine to check that. Right. Okay. What else can we assert on opening a new nursery from an empty directory? I don't want to test too much of the internals of this other than to kind of recognize that they represent some side effects of the recovery process. So, okay, so that's a fresh nursery. Let's work on recovering an existing nursery. So this is going to require recover nursery. Okay, so the other thing that we need to do here is just to be sure. I think that this happens when it's dropped, but we need to make sure that we do close that that temp directory. Okay. And I don't think, yeah, that doesn't need to be mute to close. It just consumes it. Cool. I want to see if there's impl drop. Yes. Okay, so maybe doing close unwrap is not absolutely necessary because it will do that on drop. Okay. So perhaps all these dir close unwraps are unnecessary in our code, in our existing tests. So I may just go and remove them. Yay for RAII, right? And dropping values when they go out of scope. Okay. So let's test recovering the nursery. So here what we're going to do is we'll go ahead and make a directory like we did before. And then we're going to make an anonymous scope here that opens that, similar to how we did in the fresh nursery. Okay. And then we're going to write something to it. So this will force it to both say as bytes. Yeah, let's do as bytes to owned. what I'm trying to do here is make sure that we have things that we can, you know, read back later, right? To owned. Okay. And that is going to return a result of echo command. So we should get we're going to unwrap here. We're always use panicking things in tests. I don't know if that was clear. Okay, so then we'll do a quick assert that commands is empty. And there's no explicit close. And there's no explicit drop on nursery, but note here that if you drop a file, it will close that file. So here, then we drop this nursery. And then we're going to do that again. Okay. And let's say this is going to be the file, right? We're just going to do that. This is going to be the file that we expect to be promoting. And we don't need that mute yet because we just want to make sure that this is recovering. So we're going to do assert EQ here of now we're gonna have to make sure that our stuff is we have partial EQ on command, which is not that hard. I think we'll just add the derive for that. So we're gonna say, and this is gonna be sum promote file path is going to be recovery data, and target level is going to be 10. And yeah, it's complaining that, you know, it can't compare those. So we need to go back up here and we need to derive partial EQ. I think we can do full EQ here because there's no floats. Yeah. We do not need ORD on any of this. Okay. What else do we need to do here? We can take this and say okay, why don't we do this one above, and we'll borrow that. Okay, what else do we need to do with nursery? I think that there's another thing up here that we should test, and I think that we get the metadata of the file. We can get the length. So let's do excuse me. Okay, so let's do assert equal 0. of log, we're going to do standard fs metadata of log unwrap len. Yeah. Okay, we want to make sure that, you know, this file is open. Yeah, I don't know if this, here, let's run this test real quick and see if it's going to crash. Yeah, fine. We don't care about that. Okay, so that was fine. Even with this you know, opening the file by starting the nursery does create it on disk. So I think we're fine there. All right. Let's ignore that for now. We don't absolutely need it. I think we'll want to do some of these things. So let's copy that into here. And these. And we can undo that. This is mostly about like recovering a nursery always results in an empty nursery, but potentially with a file that gets promoted to the next level. So that's the main difference there, and I want to demonstrate okay. Okay, so let's reorder these. I want to do the writing enough values to force merging. And maybe we can take the numbers off of these. I'm a type of person who likes to make lists, in case you hadn't noticed. Okay, so we're recovering existing nursery. That's good test. We've got the fresh one. I think we need to do these two because they're basically the same. So let's reread these or rewrite these descriptions. We want to write a KV pair and read it back. And we want to delete a KV pair and read it back. Because this still has to, the nursery still has to act as a key value store, even if, you know, part of its work is, you know, collecting up the data to be written to the into the first level. And I think that right, so this returns an option of value, right, and this is just get it out of the in-memory data. And then we'll deal with the more complicated, you know, write enough values to force merging and promotion. Okay, so let's do these easy ones first. Write and read. Okay, so we're going to do a lot of the same goop here. We don't actually care. We don't actually care if it has any data in it to begin with, right? Not for this test. But what we will need to verify is that the nursery log gets written to. And I don't know if we do fsync on this. I don't recall. We'll have to look through the code to see what we do. But yeah, let's go with. We're gonna have to check the length of that. Okay, and then I'm going to copy this stuff. Okay, so there's our nursery opened. Let's add something to it. And we did this up above. We can copy paste that. Okay. Right. Okay. And we'll do a quick assert there. Commands is empty. So we don't have enough data to have done anything there. And then let's do, we're going to have to add partial equal on this as well. Right. Okay. Let's do, we need to check the value, right? So we're going to clone it here. So after we add, we want to make sure that the commands are empty. And then we're going to do read the metadata of the nursery log. So I'm a little tongue-tied today. Log, right? So we want to, is that correct? No, it's len, not size. So the length of this file needs to be greater than 0. The other thing that we could do is do assert any. Right? And we can say nursery log was not written to as the failure thing there. Empty nursery should not create, should not cause merges or promotions after one key is inserted. That's a really detailed message. Okay, so we have added the thing. Now we want to read it back. So let's do assert equal, and we're going to say value plain value, right? And we want to borrow that so that that's you can't compare references to real values. And we're going to do nursery get value, and I figured we would need to do this, but I should have done it earlier. Okay, and this is, key.clone, and we will do borrow key here. Okay, but this returns options, so this needs to be right. Some okay. I don't know if there's anything else to test there, right? So write and read. We'll do something similar for delete and read. The interesting thing there, maybe we should do something like write the key and then delete it as well, because that will result in multiple entries in the log. I'm starting to see some places where we could extract some things as functions, things that are repetitive in here. But let's not overcook it first time through. I think I'm going to copy paste modify this for doing deletes. Okay, delete and read. Okay, so we don't need value, but we do need delete. And here we're going to say this is value deleted, right? That should be easy enough. I think it's probably wise for me to get cargo watch x test. And we'll focus on stuff in source. And that did not do what I wanted to do, did it? No, that did not do what I wanted to do. Let's do nursery. Did that focus? Yes, so that ran all of those. And let's pull that over here so it can run on the side while we're writing our tests. Okay. The thing is, it's gonna, because those are integration tests, it's gonna run those regardless. I can't get it to focus this stuff completely. Okay, we have two more. So what is the condition for forcing merging? We need to look at write internal. So this is looking at, right, so we do write all and sync data. So we do sync on every write. That is going to be a bottleneck. There's a set of very subtle trade-offs between f-syncing on every write versus deferring f-sync. The potential for lost data obviously is a concern there. And I'm seeing here a few things that we can possibly add to our test down here, in that so if we write and read, we should say not only does the log, we should make sure that the nursery dot total size is not 0, right? Let's go ahead and put that in there. And it's going to run that. Okay, so tests are still passing. Okay, so if the in-memory data is big enough to promote to the next level, so we need 2 to the 10, so 1024, in order to trigger that particular condition. But if there's been 512 keys written, we should get we should get a command which is to merge, right? Okay. So what I want to do is let's figure out how to do this. Trigger incremental merge. Okay, we're going to do a lot of the same stuff here. Okay, and then we're going to say we're going to keep a collection of commands here, and I could possibly do this as a like an iterator with a collect at the end. Let's do it this way first. So let's say for I in 0. Now we need to do at least half of the size of the smallest level. So we're going to do we're going to create some keys and values, right? And then we're going to write them to the nursery. Step commands. And then we'll do commands extend step commands. And that way we're just glomming it on. And then, okay, so here, what is that? Oh, okay, so we formatted this. We need to do to owned. That's kind of a pain. We've allocated twice there. Is there a string thing to go to a vec of U8s? Not into raw parts. Into bytes? That's what we want. That's rather than as bytes. It's worth knowing that it's not always obvious, but the Rust standard library has particular style. So if you see as something, it usually means take a reference to it. Maybe converting its type in some respect as you do that. But if you have into, that's like consume this thing and produce this other thing. So like there's the bare into, which is good for the from and into traits, where the resulting type is obvious or is annotated. But in this case, and there's a lot of other cases where it's like into and then the name of some type, even if that is not an actual type, an abstract. So into bytes is what we want. And maybe we could have done this. No, up here, because this is a stir, not a string. So it's not owned. We could do to owned into bytes. Stir does not have into bytes, I don't think. Right, this is on string, not as deref, right? There's no, there's bytes, which returns an iterator. We don't want that. Yeah, there's no into bytes on stir. So So this is what we want. Okay, so we should do a real quick assert that commands is not empty. Okay, and we should say should have produced a merge. Now we could do an assert EQ. Let's do some of this stuff as well. We want to make sure that the nursery was written to, that we're tracking that. And I think that we need to make sure the nursery log has been written. So let's go ahead and do that. Okay, so now we need to look through the commands, and I think what we want is to see, it should be like 512 or 513. And the command should I'm going to make this a little bit more strict, because I think that we want to see one command. Okay, now this is going to be slower because we're writing stuff, and it's f-syncing on every write, right? Okay, so we did get a command in there. So let's do an assert EQ on commands 0. Which is going to be, it's going to be a merge command. Steps, let's say 512. We're just guessing. The target level is always going to be min level, right? So let's see if that passes. And it did. So what we're seeing there is when you hit half, it's going to say, do this many steps. Okay. So we need to do something similar here. What we want to do, though, is write 1024 keys. We did this in the public API test. It was kind of slow. But what we're going to do is okay, so I could have done this as a loop with a flatten, or I'm sorry, an iterator over this with a flatten. But we're not gonna bother with that right now. I think that this is clear enough. I'm just put write 512 KV pairs into the nursery, triggering incremental merge. Okay, and let's do we're going to need a lot of this, so I'm going to copy paste the whole thing. Interestingly, this is going to be trigger promotion. Okay, so we're going to do okay, so we're going to need that, right? So now we're going to we don't care about incremental merge. but we're going to see them, right? Because that it should happen actually twice. Okay, so we're going to do 1024. Okay, we can still assert that nursery log was not written to. This is going to fail. We can say, I can guess that it's actually going to be 3. Right, because should have produced 2 merges and a promotion. And this one is going to be, so command 0 is going to be the first merge. They were triggered at 512. And then there's going to be you know what, let's, instead of doing each one, let's do this, right? Okay, so there's going to be a merge, and then there's going to be a promote, and the path is going to be, we're going to clone that into there. Target level is going to be 10, and then there's going to be another merge command that comes after that. There is a little bit here that I'm concerned about with when you promote a file. Yeah, and that failed. Okay, so here's an interesting thing. It closes or it truncates the nursery log. So here we want to do, we want to have a different assumption. It was not truncated after promotion, right? Okay, now we'll see if the command's equal. Okay, this passed. So I was going to say, like, what am I concerned with? I'm concerned with the potential synchronicity of every time that you close out a data file, you also submit a merge steps. That concerns me. I'm going to do one of these for the data file as well, because I think that that's important. And this is going to be data. And then we're going to say nursery was empty. Okay. Oops. Semicolon, please. Okay. Yeah, I need to think about, what the potential implications of this are. And Greg, if you happen to be watching this later, maybe you can chime in and we can think about that, because the fact that the last step of, so like when I've written the 1024th key, I'm getting both promote a file and do incremental merge. It feels a bit like this would be spiky. And maybe that goes back to the issue of that we referred to here. And I'll have to read that issue at some point. Okay. Why did I end up there? Okay. Okay, so we're gonna make a quick commit. Okay. And we're in session 13. And this is going to be better tests for the nursery. Okay. I would like to go for a little bit longer. Maybe let's get some stuff for the writer. And we don't have to have all of this stuff set up for that. Let's see here. Let's test writer. Okay, so there, it didn't match any tests in there, but we're gonna keep that going on the right here. So okay. Let's figure out what we can do for the writer. What are some things that we can test? And we're going to do similar to what we did here in the nursery tests. We don't need the min level, but we do need this. Okay. What are some things we can test? So we want to test so we want a round trip test, which is write some values to the to a file and read the file back, right? Okay. What else do we want to test? There's an invariant that writes must be in order, in lexical order, right? Byte order. Byte lexical. I don't know how to specify that. We want to check values and tombstones are tracked correctly. Tombstone counts are tracked correctly. I would love to be able to assert some things about the internals of, you know, the blocks as they're written, but I think that might be more interesting to look at as reading back what it wrote. Excuse me. So I think you know, there's some things about, you know, you need at least 8 kilobytes for a block size, or like that's the maximum. It's not that it's a fuzzy maximum. It's like if it goes over this size, then we should create a new block. Okay. So blocks are closed when they reach 8 KB. There's some other interesting things like if when you go to close the file, there's a pending block that has only one, a pending inner block that has only one entry in it. So solo inner nodes are pruned on close. Let's see. What are some other interesting things about this? We can say that if there's nothing written to the file, then yeah, so we want to say that you can write an empty file. Write an empty file. Right, that's a potential branch point we should be checking on. And then we would have the trailer, right? Yeah, I remember us going through this and like, figuring out what the encoded size of an entry is. This doesn't account for compression, of course, but yeah, tracking the right. So we already have a test for out of order write on something. Okay. Right, and this is we're building up the inner nodes of the B tree as we flush a node at a particular level. Okay, I think that this is a pretty good start. I am actually kind of running out of steam, but let's try to do the round trip. So write some values to a file and read file back. That's a pretty simple thing to do. And it doesn't require the file to be very big at all. So let's do that. Round trip. Okay, so we are going to do this dance again. Unwrap. Okay. And let's see. Our data file is going to be dir as ref join test.data. Yeah. Okay. Again, it doesn't matter what this is because it's we're not we're considering the writer outside the context of the entire system, just as writing a single file. So let's do. Let's see what we need to write. So add takes entries, right? Okay, so let's create a KV entry. So let's say key. And we're gonna have to do this dance again, right? If you don't know what I mean by this dance, we're doing some of the same things we did in other tests. Okay, so this needs to be key.clone because we're going to compare this later, right? And this needs to be value.clone. Okay, and then we're going to do make a deleted one. Okay. And timestamp is none. Okay, so in making sure that we get this in the right order, because deleted comes before key. We're not testing the order of writes here. We're testing. I didn't want to make everything smaller, but okay. We're not testing the order of writes here. We're testing the write and read back. Okay, so we're gonna say let mute writer, and this is going to take data, right? And does that return a result? It does. So we're gonna unwrap that. Okay, and then we're gonna do writer add. We're gonna add deleted first. Add KV. And then we'll do writer.close. Now I think that those return results as well. Yes. So we need to unwrap all those. So before this can be a separate test. We've already gotten it written as a separate test. So let's do writer.close, which is going to consume it. And we need to unwrap that as well. Okay, so then we're going to use create format tree. I'm going to say let tree from file and data. All right, so we've written the file. We're going to read the data back. And we need to unwrap that. Okay. Yeah, fine, it's not used. Okay, the test passed at least so far. We know we can write things. So we're going to say again, the entire internal API is based on getting entries, not um, not the internals, the values, because the entries are what are important in the internals. It's on the outside we don't pass those entries back. Okay, so let's do some assert EQ on here. Get entry, and let's say key, right? And this is going to be we're going to do some clones up here. This, remember, this code doesn't need to be efficient. It needs to test the functionality. We're going to assert that that's equal to kv. Now, this needs to unwrap, and we can do sum kv, right? Okay, so now we need to derive partial equal on entry, which I suspected we would. So let's jump to entry. And we can do EQ as well. Okay. So that passed. And then we also want to do the same for deleted. Okay, so we got none. Why did we get none? We should get a tombstone there. So let's do, before we do that, I think it might be worth looking at okay, so we basically didn't find it in the list of entries in that block. What we can do, though, however, is we can iterate, and let's see. Let's do entries owned just for safety. Entry. Well, we can do that. Collect. That returns a result, so let's do unwrap on that. Okay, and then we're going to debug entries. And and then let's go ahead and do that, and that'll panic, and we'll get the debug printed out. Okay. So this is interesting. We got deleted. I think we have some problems here. Note that we expected 100, 101, 108. What we're getting is 116, 101, 100. So these are getting truncated. We have a problem of those 4 bytes being missing on the beginning of the key. Now what's interesting is that, and maybe it's just that key is short enough. So we actually have a bug here, and I think that I don't have the energy to fix this time, but we should be testing this and finding out why this gets truncated. Yeah, because we get TED, not DELE, TED. So we have a problem in our writer, and I think that's important to figure out. It's possible we didn't allocate something correctly in terms of enough space. It's possible that we have a synchronization problem. We'll probably want to look at the root block of this tree to see what its contents are. And I think that it's actually the root block it's just going to be these 2 keys, right? There's not going to be an internal node because there's nothing to be written in there. But it'll be good to know why. And it's interesting. This is the first key in that block. I wonder if there's some kind of problem where we're truncating or consuming too much, and then, yeah. Okay, this is all good stuff to know. We have an interesting bug to fix for next time. So let's wrap it there. I'll make a commit source, and this is session 13. Initial tests for writer with a big bug in it. And I'll push that. And so all the code's up to date there. If you showed up today, thank you for watching. I'm going to close it out there and get some rest because I have a big day tomorrow. Thank you for coming, and we'll continue on testing this next time. Cheers.